Okay, hi. For science today, we're doing our very last part of the flight, of the 4 forces of flight. And then you are going to have a little task of designing something that's related to this last force. And this is going to be getting into a little bit of our kind of like a little preview for our flight unit, which we're going to be doing, like building paper airplanes. Okay, so here we go. All right, aerodynamics. Okay, underneath of the fourth one that we have, which we have not done yet, which is drag. Okay, right, we had lift, which is up, we had gravity, which is down, we had force, forward, which is like the forward motion, right? And then we are now having drag. Okay, so drag, I guess you could write this in if you wanted to. I can recognize that streamlining reduces drag. Okay, cool. All right, so force number 4 is drag. All right, so a couple little notes. This is mainly the page of notes for today, and then beyond that, it's just some examples. Okay, so force number 4 is drag. Drag is the backwards pulling drag is the backwards pulling force. Okay, so it's working in opposition to thrust, which is the forwards force. Yes, okay, so this force opposes thrust, which is forward. Drag is related to, okay, now this is kind of getting a bit more technical. Drag is related to the number of blocking surfaces or the surface areas that do not allow free flow of air over or around them. So basically, okay, if we're looking at this plane here, okay, where would be the blocking surfaces on this plane that are reducing, or I guess are like reducing how streamlined it is? So if we're looking here, well, right here, right? This windshield, this would be a surface that is blocking the air from easily slipstreaming over top of it. So yeah, we could probably think maybe of a little bit more of an aerodynamic design. If you wanted to get like really race like fighter jet, it'd be even like slimmer, right? That would be more aerodynamic. There would be less blocked surfaces. So surface area, this is kind of a little bit of like a math thing. So basically surface areas that do not allow free flow of air over or around them. Okay, but this is still a pretty good example, right? Because it's still gonna let air over it. Imagine we had like a hook going this way. It's catching the air like a parachute. Would that allow air to freely flow past it or around it? No, right? It would catch it instead. So that's why everything here is like looking pretty sleek. Okay, so basically this is what engineers would be trying to do when they're designing aircraft or anything that has like an aerodynamic design to it. So by reducing the number or size of these areas, of these block surfaces, the object becomes more streamlined or, more aerodynamic, which makes them, look like fast and cool. Okay, so that's basically kind of like, that's the most important stuff for today to write down. Okay, this you do not necessarily need to write down. You can just sort of watch this. Okay, so a great deal of focus is spent by the industry each year improving the aerodynamic qualities of objects such as automobiles. Or, like bikes would be another example of something or planes. Aerodynamic cars are more efficient and are able then to move faster and easier. So if there's like a spoiler, I think DR mentioned a spoiler last week. A spoiler is this like kind of like little bit that's over top of the back of a car, and it would like help to reduce the amount of drag, and it would help streamline the air over top of the vehicle so that it goes a little bit faster. And this is a pretty cool looking car, right? Like there's not many block surfaces, and the ones that are designed really well. So even if you were to look outside and like look at some of the cars that you see, like, oh, how aerodynamic is that car compared to the next car at the traffic light that you're parked next to? All right, so here, okay, an undercut, a car's underbody of aerodynamics. Okay, yeah. So again, even like the underside of it, they'd have to think about like not just having like an instant like block, right? They even have this kind of like a little bit streamlined design, which is so cool. So the fast moving air has low air pressure, and then the slower moving air has higher air pressure. So if there was like yeah, I guess they'd want to make sure that it's kind of going like up a little bit towards the end of the car. Okay, so here, which one would be more aerodynamic? What do you think? Okay, I'm not going to say it. You guys can probably figure this out. Why? That's kind of the most important thing. Okay, the next one is this. Whoa, which one of these do you think would be more aerodynamic? And why? What could you use about block surfaces or surface area and the word drag? Okay, so this is your like little tiny bit of homework. Think of a sport or activity where aerodynamics matter. Okay, I've said F1 racing or bike racing do not count. Okay, so try to think of something else. Where would the aerodynamic design of something matter? Where would that be an important design component? Okay, so we talked about cars, so maybe think of something other than cars. Okay, so, and this is kind of important to sort of like think about this. Okay, so here, aerodynamic design or not. Okay, so this block surface, right? A lot of block surfaces on this, and also even look at the shape of it. So here the air is coming into this, thinking it's all happy, then boom, it has to go somewhere. So it has to go up and then over. And then this is what's created actually behind any type of block surface, is this thing that's called an eddy. And an eddy, you might hear that term if you spend some time like whitewater rafting, and there would be these eddies that you could possibly get pulled into in like a whitewater rafting, and that kind of like sucks you back, and it's like basically it's turbulence, and it's like air, well this would be like, I guess, like air turbulence, or or like a liquid turbulence, and that kind of like, you know what it's like when you're caught in turbulence in an airplane, right? It kind of like tosses you around because the air isn't moving in a slipstream motion anymore. Compared to this one, we know this is like a beautiful looking airplane wing with a pretty decent camber to it. And yeah, you can tell how much more efficient the air is able to flow over the top of this. Okay, so that was pretty obvious, right? Like which has an aerodynamic design and which doesn't. Okay, so now this is your main thing for today. Design your own experiment to prove the same idea. Okay, so this is the scientific idea. The change in the surface area will affect the amount of drag. So what could you do? Does the change of surface area create more or less drag? I think that if there is decreased surface area, there would be what? Because what do you know? Okay, so as you should put in your hypothesis. Then for materials, now this can be like totally up to you. Like what would you design for some type of experiment to show this? Or maybe even it's like a model. Maybe it's like you don't have to necessarily make anything. Like maybe you just want to, like, you had a couple like things around your house that you're thinking, oh yeah, like this would be more aerodynamic than this. Like if you have any, like, I don't know, this is like, you could use this as an example. If you had like just like a little like race car, like a little toy car, could you set up an experiment that would be able to show the differences in the aerodynamics and how it affects the amount of drag that something is produced? I'm even thinking, like, maybe I had my mouse. Maybe you have different types of like mice in your house that you want to talk about, like which one has a more aerodynamic design, and then how could you test this? Like how could you actually like try this? Yeah, and I don't really want to say too many more examples, but try to be creative. Like what else could you do? Maybe you could even make something, because we're getting into paper airplanes. Maybe that could be an idea. Or what else has to move? What else would move? Like how else could you think of something else to design? So you could even use something super simple like one piece of paper. Rip the piece of paper in half and then think, how could I show this idea with even just like a single piece of paper? Okay? All right, so that's your task for today. Think about it and try to design something. And then, yeah, we'll see you. Yeah, that's it, I guess, for today. That's why we did this lesson. Did we do this lesson first? Yeah, this is first. Okay, so think about this. Design, play around with your ideas, And then, yeah, I'll see you at 2 o'clock for social studies. Okay? So think about it. Have fun.